Okay, I want to mention one last thing here at the end. And that is, notice how we solved for this. So basically how we found this formula is we differentiated by the product rule, a product of functions, and then we integrated both sides. So we can come up with a general formula that has an integral in it and that we could use for product of functions. And that brings me to my next point, which is that we solved for this one, which has g prime and f, not this one with f prime and g. But we certainly can solve for this one instead. We could use the formula in this form where we have g prime of x, f of x here on the right hand side instead, and f prime of x, g of x. The reason behind this is just based on how you choose your variables. So if we have this integral again, and we say we want f prime of x to be e to the x and g of x to be x, which means that g prime of x is 1 here. After integrating, f of x, original function, would be e to the x. And in this case, we would be using this form. Why is that? Well, it's because we let the sort of derivative function be of the variable f. If we let our derivative function initially be of the variable g of x is equal to e to the x, then we would have to find this through integration, the original function, e to the x, and the other function, not the derivative function, the function, f of x would be x, and derivative would be 1. So we would be using this one. We would be using this general formula, sort of. Why? Well, it's because, again, we defined our derivative function initially to be of the form g prime of x, which we have up here, g prime of x. So you could use both sides, both integrals. You could solve for both of them. You could either use this one or this one. Sorry for the scribbles, just want to make things obvious. And the most important thing is not how you define your variables, whether it's f, g, u, b, a, that doesn't really matter. The most important thing is what you choose to be a derivative function and what you choose to be just a function that you're going to take the derivative of, and here take the integral to get to the original function from the derivative. So it could be with any variable, a, b, c, u, v. This is just the most important part. What you choose to be the derivative function that you need to integrate and what you choose to be a function that you need to differentiate. Based on the rule, the general rule you could use, or by looking at the problem and thinking what would be simpler to integrate and what would be simpler to differentiate. Here, obviously, I would let the function be, let a function f be x because it's easy to differentiate. You just get f prime is equal to 1. And I'll let a derivative function g prime of x be e to the x because it's easy to integrate. I'm repeating myself just so it sticks in your minds. So g would be e to the x after integrating. See? All based on what gives you the simpler results.